Hey guys, and welcome to Top Channel 101. And today we're going to be making this growing thing. It's just a bunch of roots that grow on a text, editable text, by the way. So I can change this to something like, and I see that would update, and the animation is also updated. The path the roots take is updated, and I can even change the beginning position of that path by just moving this empty. It's all procedural in nature. I can control a lot of things. Say again, like I said, the text is editable, so subscribe. Project files are going to be on my Patreon page, on my YouTube membership page, and on Gumroad. All links are going to be provided in the description. So let's jump into this. Okay, so first things first, we go to geometry nodes and add a plane. This is just going to hold the geometry, and we can start with our text, which is a string to curve node. Makes it easy for us to type in whatever we want here and convert it to a curve as well. So I'm going to expose this and just call this grow like that. Transform this here 90 degrees on the x-axis, just like that. Make some space here. Fill this in. So I'm going to fill curve, just like that. Let me get a thicker font, like Arial black. I think it looks better. Turn on random colors. Okay, that's where we are. We can, since this is a mesh, we can extrude it that, but we're going to end up with this side being empty. And I want to offset to extrude all faces, not just individual faces. So let me do something like that. I don't want this side to be empty, so I'm just going to merge the original with this, so we have something like that. If I look at my normals by going to under the face orientation, you can see I have this side flipped, so I'm going to use a flip faces to flip that. These two meshes are different, so I'm going to merge by distance so that this is a single mesh. One thing I need to do before I merge, I need to realize, because right now if I do a scale element, you will see that these are two separate things. Actually, if I do this after the merge, it's still going to produce the same thing, because these are instances, and you can tell from here that we're working with instances. So we need to realize those instances so that this becomes a single mesh, and you can see now it's merging as a single mesh. I'm going to remove that and change back to the normal view like that. I'm going to bring in an empty. This is going to be our location for the start of vines, so something like that. And then now let's start working with the vine. So let me just frame this into text. Now we go to the vines. So the vines, we're going to use something called the shortest path. It's basically a node that can create path from a starting point to any of the vertices you have selected. So we're going to do that. If I do shortest path here, you can use this shortest path in combination with the edge path to curves, and you need a base mesh. You need the mesh here, and this should basically create. This goes into the next here. So we're going to need a start vertex. For those, we can use a random value. Just select some random vertices on this mesh. Remember, this is our mesh. So we're just going to select some random vertices around this, and then the end vertices we can create a mask using the position node. Basically getting the position of each vertex we have in our mesh and comparing it to the position of our empty, of this empty here. So let me select our plane, bring in the empty. If I use the math node, the vector math here, I can get the distance of this empty. Let me make sure I'm using relative, so I can get the distance of this empty. And if I look at that, so you can see that whenever I move this, we get that mask we want. I can use a compare node, and you can see we can generate a nice mask. But our mask, you can see, because we have a lot of triangles, our mask doesn't really look very good, and it's going to cause some issues when we connect this. And maybe let me do that here. We need this selection to be our end vertices, and now we should get something. And you can see it doesn't really look good. We still have the functionality we want. The issue now is that we need to make this look good by getting proper geometry out of this mesh. To do that, I'm just going to remesh this by first converting it into our volume, mesh to volume, basically giving us something like that, and then volume to mesh. yeah, you can see now we get a better mask, and we also get a better mesh topology, except we're not seeing the words anymore. It's too blocky. So we can come here and play with the threshold, or play with the voxel, but it doesn't have to be perfect. You don't need to capture all the detail in this. So you can keep it simple. We just want to get the silhouette of this. You can even go with this, but you'll see that if you don't have this mesh connected, we're going to have an issue where the vines struggle to connect to other letters. So make sure that you have some connection between letters. We are mostly going for the silhouette of the mesh. We don't really care that we get the entire detail of the mesh. Now you can even use adaptivity so that you have some, yeah, something like that. You reduce on the polygon count. And now instead of using this, we can switch it out to use this. You still have a lot of settings you can play around with here. You have this here. It's just controlling how far the roots are going to grow. So that could be useful. And remember, we can still use this to control the position of our roots. But this, it doesn't look like roots. So what we can do is use a set position and smoothen out those sharp angles we're taking. So I'm going to use a position node and just connect this to the position and blur. Use a blur attribute. Make sure that this is set to vector. Blur the results a bit. And you can see now we have something that looks more interesting. I'm going to change this from greater than, because I'm saying that the path is ending at our empty instead of starting at our empty. So let's try using the less than, and you can see now the path is starting from the empty. And I think I'm using too much here. Then let me add a resample node so that our curve have more samples, and that will give us better, yeah. Now let's reduce this subdivision. So there are a lot of settings you can play with to get the results you want, but you can see we basically getting somewhere with this. Okay, so the more count you have, the more detailed the roots look. Now we can also use the edge cost to add even more detail. So if I use a noise map here, a noise texture, connect that to the edge, I can play with this, and you see we even get more detail. Let me subtract. Yeah, you can see we can get even better. Yeah. So if we merge this with the original mesh, not the volume mesh, not this, but with this here. So I'm going to do a join. Just join these two together so that we can see what's happening. Yeah, you can see that our roots are pushed away from the surface of the mesh. The easy fix for that is just using another set position node. Just going to add it here. Another set position node just before these around here. And if you plug the normal into the offset, you're basically scaling the mesh out. This is too much, so I'm going to use a math node with the scale option to control how far this is scaling. So we are basically pushing things out or in along the normal. So right now we are pushing them along their own normal, but what I want to do is to use the normal of these faces to influence the scale so that they are pushed onto this mesh instead of using the curve's normal. To capture that normal, what we can do is look for the nearest face to this path by using a sample nearest surface, and I want to get the normal of that surface or that face. So this is supposed to be a vector, and the surface we want is this original text. So I'm going to just, to keep things organized, I'm just going to add a route node here and just use that here. Now if I plug that, now you can see that we can push these a bit closer or further away from the mesh, something like that. Now, another thing we will notice is that if we look at our spline count, we have a lot of splines, and we have over 3K splines. We're going to give them some thickness, and that is going to double or triple the polygon count, and it's going to slow down things a lot. So for optimization purposes, I'm going to come here after the set position, yeah, around there, and do a delete geometry and just delete splines based off a random number. So I'm just going to randomly remove some of the splines we have so that we don't have nearly as many as we have. So like that. We're going to lose some detail, but yeah, not too much hopefully. So around that. And I'm going to first come here and just disable this for now. Actually, let me remove it altogether. We can come back to it if it's needed. So yeah, we don't want too many of these. After the delayed spline, we can use a curve to mesh and then a circle with a count of 4. Just connect that. That's too much. The radius is too much, so I'm going to put this down a bit. Yeah, you can see what we have, and look at that polygon count. It's just gone up quite a lot. Let's add some materials. So I'm going to use a set material. I'm going to keep things very simple here. I'm going to use a white material for the text, and then roots. Let's just use green material for the roots. It's a bit darker. Now we want obviously the roots to become smaller as they go, so I'm going to just come here. Before we convert this to a mesh, we can use curve radius, and yeah, we can use the spline parameter. This usually comes with this factor, which is basically the length of the spline. And you can see we have something that looks like roots, which is nice, and we have the functionality we want there. We can change the text already. If I say like, you can see what we have. I'm going to come back here and see. Let me see, because these are starting. I don't want them to start from here. Let's see, change. Yeah, we have to change the radius here. Yeah, something like that. Yeah, this is much better. Okay, so yeah, you can see these are a bit floating. That's why you use the denominator of this mesh to scale these vertices in so that they're closer to the mesh, to the original text. So I'm just going to use a set position here and add sample nearest surface. Basically, find the nearest surface to the path. Now we want to get the normal and basically use that, push. This is the mesh we want to capture. Use that to push these meshes around. So I'm going to use a vector math node like we had set up before using a scale. Just push this closer to the mesh so that it's kind of tighter. If we try using, let's try using the original mesh. Yeah, actually we can use this volume mesh because it's producing better results. Now, one other thing you will notice is that all the roots have the same thickness. I want to change that, so we can come back here to the set radius, have some space, and we want to randomize each vine's radius. So I'm going to use a random value and just multiply it with this value using a math node. Multiply this here. But the problem with this is that it's not going to be per vine, it's going to be per vertex. And if you look at that, you see these dark dots instead of seeing individual vines. That's because we need to set the ID of the random node to use splines instead of vertices or points. So to do that, I'm going to use a capture node here and get the ID we need to capture the spline ID. And just use it here. This is supposed to be an integer. Use it here. Map this to 1. And now you can see the individual vines. So I can look at this, and we want to have some bigger vines and some smaller vines. Now from there, we can do a trim effect. So if we want the animation is very simple. We can do a trim effect just before the set radius. So I can do a trim curve, and now it grows by using this control. So I can even just do a group input here and just expose this start parameter so that we can control it over here quite easily. Now the other part is these leaves here. And that is easy. We just need a leaf, and just going to create a simple one here. Give it a subdivision, shape it like a leaf, give it its own material. Just going to use a pink, create some slight animation here so we can see what we are doing. Have something like that, grows. And so for the leaves, what we can do is we need to come before the trim, so around here, and do a distribute. So we have this because we want to distribute points on faces, but this is still a line, so it won't work. These are still lines here, so we need to give them, basically do this setup here again, curve to mesh, and just use the same curve here. So we have something like that. So the reason why I'm trying to add these points, which are basically going to be our leaves. Let me do that instance on points. So leaves. So I can, yeah. So, and let me add the rotation of these. There may be vector math. Add a vector math so that they are pointing down. I want them to point. We just get this rotated on the X 180. That scale should be down like that. And I want to randomize the rotation a bit. So I'm going to use a random value vector, but I want to mostly have them pointing down like that. So yeah, like I was saying, the reason why I'm bypassing this mesh that has the trim animation like that is because if you use it as the distribute mesh, so for example here, and we play back here, because the mesh is changing, the density is also going to change, which will make the leaves jitter like that. We want this to be stable, so I'm creating a separate mesh that does not have the trim animation on it. So if I play back, we have the animation of the vines, but the leaves are not animating because they are not part of this section of the curve that is animated. So to have them animated, we need a way to capture this animation data and transfer it to this mesh. Like I said, we can't just use this mesh here because the leaves start to jump around like that. So that's why we are creating a separate mesh for that part of the leaf. For the leaves, we need to capture the length of this curve before we trim it. So around here, we can, since we're using it here, we can capture the length of the mesh, so spline parameter. So actually, let me, just to make sure things are easier to read, just going to branch this off here so that we know that this is just the, so this is the trim animation. So let me just frame that. And now here, we are branching off to another curve and we're capturing the length using this factor, and you can see we're getting that here. And using that mesh, we convert it to its own mesh, so that we can instance distribute our points, and we turn those points into this. Now, since we have this length here that we have captured, we can connect that directly into the scale of these instances, and we should have the scale of these leaves influenced by the length of the curves. So this is what we have, but the leaves are too big. I can add a float curve, scale them down, and I want, when we have this animated, for example, if I add a math node here and just subtract from this length, I want this to grow to a certain scale and just stop around there, so something like that. So if we do this, you see we have that animation we want. It doesn't matter how much we change this value. The leaves scale up to a certain level and then just stop scaling because they're being clamped by this float curve. Remember this start value that we are using to animate the growth of the splines. We can now use that. It's under the group input here as the start value, Since it's animated, we can use it here as well. And you can see now we get our animation. Quite simple. So you can see we get a nice simple animation without too much hassle. Everything still works. I can change the start position. When you see that you have moved the start position and you see nothing, just come back here to the bandwidth or to the volume settings. Try to play with some values and until you see things happening. And yeah, that's it. If you want the project files, they're going to be available on my Patreon page. Let me check one thing. Just get that. Yep. So yeah, you can subscribe. Now maybe one other thing, I don't like that each leaf here has the same scale, so I can further randomize that by adding a random value here. So I'm just going to add a random float, just multiply that to this so that some leaves are smaller. Yeah, thank you for watching. I'll see you in the next video.